Good day to you from ChemHelp ASAP. In this video we will see a nice example of an SN2 reaction pulled from the chemical literature. The work in this video was reported in an issue of ACS Medicinal Chemistry Letters in a joint effort of two scientific teams, one at Amgen, led by Dr. Victor C., and the other at Carmot Therapeutics, led by Dr. Daniel Erlanson. The citation is on the following slide as well as in the video description. On the screen is our reaction. It is an SN2 reaction, but it involves two steps. First, our starting material needs to be deprotonated to form our nucleophile. Second, we treat our new nucleophile with a primary halide. All right, let's look at step one. We have a base, sodium hydride, over the reaction arrow. That base is strong enough to deprotonate the NH group in our starting material. This ring system, 6,5 ring system, is called an indole. Normally NH groups are tough to deprotonate, even with a strong base like sodium hydride. Indoles, however, are more acidic and have a lower pKa around 16. Not so different from water or alcohols. This particular indole will be even more acidic, with the electron withdrawing carbonyl providing additional resonance stabilization. The hydride removes the proton to form the deprotonated indole. So let's draw our deprotonated indole. So our nitrogen will have a negative charge. Finish the structure. Perfect. This anion is a nucleophile, and it sets us up for an SN2 reaction in the second step. The halide in this case is primary. There's no question about whether we can have an E2 reaction competing because this halide doesn't even have a beta hydrogen. It's an SN2 all the way. The nucleophile attacks, kicks out the bromide, and forms our expected product. Indoles as potential nucleophiles in SN2 reactions would be rarely encountered in undergraduate organic classes. But this reaction is similar to a very familiar reaction, the Williamson ether synthesis. In the Williamson synthesis, we start with an alcohol, and I'm down in the bottom left. Here's our alcohol. We treat our alcohol, which is not a nucleophile, with a base like sodium hydride to form an alkoxide, a better nucleophile. And the alkoxide does an SN2 reaction on a primary halide to give us our new ether product. Our indole reaction is exactly the same idea. Number one, deprotonate to make the nucleophile, and number two, add the alkyl halide for the SN2 reaction. The Amgen and Carmot scientists used the product of the reaction to form the core of the molecule in the bottom right corner. The molecule in the bottom right corner is representative of the types of molecules Amgen and Carmot are developing as inhibitors of a protein called KRAS, which plays a role in signaling cell proliferation. In some types of cancer, KRAS is mutated, is overly active, and causes tumor growth. Blocking KRAS, or inhibiting KRAS, allows a molecule to slow progression of KRAS mutant tumors. In conclusion, the SN2 reaction is a fundamental reaction in undergraduate chemistry classes because it is a vital tool for assembling organic molecules. If you want to learn more about the synthesis of these KRAS inhibitors by scientists at Amgen and Carmot, then check out the reference on this slide or in the video description. Please subscribe, like, or leave a comment. Take care.